Dear students, in this video we will see what is a signum function and later on we will see its properties. So what is a signum function? A signum function is defined as Sgn of t. It is equal to 1 for t greater than 0. So it is 0 for t equal to 0 and minus 1 for t less than 0. So this is the definition of a signum function. Now if we want to realize this function, this signum function, so what will be the graph look like? This is t. So here we have Sgn of t. So when we have t greater than 0, we have a value of 1. So here we'll have this function. Okay, this is value is 1. When t equal to 0, it has a value of 0. And when t is less than 0, we have minus 1 value. So here we'll have a minus 1 value. This is minus 1. So this is the definition of a signum function, and here we have this graphical representation. So a signum function, we can see that it is discontinuous at t equal to 0. So here we can write signum function is discontinuous at t equal to 0. So here we can see, so at t equal to 0 we have 0 value. Okay, and it is not connected. This 1 and this minus 1 value is not connected. So this is the signum function. So for example, if we want to find out some definite value of t as Gn of suppose minus 2. So what will have value? So for minus 2 here we'll have suppose minus 1. This is minus 2. So what will be the value? So signum function has a value of minus 1. Okay, now if we want to take some positive value, suppose we have signum of 2 equal to what will be the value? So suppose this one is 1, this is 2. So what is the value here? So here we have the value is 1. And when t equal to 0, it has a 0 value. So now let us see its properties. Okay, so the first property is signum function Sgn of t, okay, is equal to twice u of t. This is the unit step signal, okay, minus 1. So the relation between this signum function and this unit step signal is this one, and this can be again rewritten as u of t minus u of minus t. So this is the relation between signum function and unit step function. Now let us verify. So now let us find out these two functions. Okay, twice u of t minus 1. Suppose first of all let us draw twice u of t. So what will be the twice u of t? So u of t is equal to 1 for t greater than 0. So twice u of t will have twice the value. Okay, so here we'll have this is the 2 value. So this graph is twice u of t. Now if we want to subtract 1, so what is the representation of this 1? So this 1 is nothing but a DC signal, okay, with a constant value of 1. So this signal is 1. So for any value of t, it has 1 value. So this 1 can be represented with this graph. Now if we subtract this 1 from this twice u of t, we'll have this function. Okay, so here we'll have twice u of t minus 1. So this point is 0. Here we have this 0. So when t is greater than 0, we have twice u of t is 2 value, and this 1 DC signal has a 1 value. So 2 minus 1, what we'll have here? So for t greater than 0, we have a value of 1. Okay, at point this 0 point, so what will be the value? So this is a unit step function. It has discontinuity at this point. So if we want to find out the value of twice u of t at t equal to 0, what will have? We have to use the Gibbs phenomenon, and from that we have to find out the average between 0 and 2. So it will have a value of 1. So we have calculated this 1 taking the average of 2 and 0 from Gibbs phenomenon. Okay, so this point has a 1 value. So at t equal to 0, twice u of t has a 1 value. So 1 minus 1. So what will have? We will have 0 value here. And for t less than 0, here we have 0 value. So 0 minus 1. Okay, this is the positive value. So what will have? We'll have a minus 1 value. Okay, so this is nothing but a signum function Sgn of t. So we have seen this first part, Now let us find out this u of t minus u of minus t. This is u of t, and here we have t. Okay, and in the left hand side we have 0 value. Okay, so now if we find out this is t, and if we find out u of minus t, so we have to find out the mirror image across this y-axis. So whatever we have on the right hand side of this y-axis, it will come in the left hand side of this y-axis, and whatever we have on the left hand side, it will come in the right hand side. So it will have a 0 value here. Now if we subtract this graph from this graph, then we'll have u of t minus u of minus t. So if we subtract this right hand side graph from the left hand side graph, what we'll have? U of t has a 1 value, and here we have 0 value for t greater than 0. That means 1 minus 0 will have 1 value. Okay, this is 1 value. So at this point what we'll have? This value is 1, because this is a unit step function. Here also we'll have this 1 value. So from Gibbs phenomenon, what we'll have? This is half, and here also we'll have half at this t equal to 0. So half minus half, what will have? 0 value. And when t less than 0, this u of t has a 0 value, and this u of minus t has a 1 value. So 0 minus 1, so what will have? We'll have minus 1 value. So here we'll have this minus 1 value. So this is nothing but u of t minus u of minus t. Okay, so this graph is nothing but the graph of a signum function. You can see here, this is the signum function. So this graph is similar with this graph. So here we can write as Gn of t. So this is the first property. Now let us go to our second property. So what we'll have here? The second property is the differentiation of a signum function, that is d dt of signum function, is equal to twice delta of t. That is, we have found a relationship between the signum function and this impulse function, delta of t. From the first property we have got signum function is equal to twice u of t minus 1. Okay, this one we have seen here. Signum function is equal to twice u of t minus 1. So if we differentiate now, d dt of signum function is equal to 2 is a constant, so it will come outside. So du of t by dt minus differentiation of a constant is equal to 0. d dt of signum function is equal to twice. Now differentiation of unit step signal is a unit impulse signal. So here we'll have delta of t. So this is the proof of this second property. Now let us go to our third property. In the third property we have signum function is equal to mod of t by t for t not equal to 0, and it is equal to 0 for t equal to 0. That is, for the positive and the negative values of t, we have this value, and for t equal to 0 value, we have signum function value is 0. So to prove this, we will take some values. Signum function of minus 3. So what we'll have? This is the function, because this is not equal to 0, t is not equal to 0. So we have mod of minus 3 by minus 3. So what we'll have? Mod of minus 3 is 3 divided by minus 3. So it is equal to minus 1. Now if we see this graph, mod at signum function at minus 3 point, suppose here we have minus 1, minus 2, minus 3. So at this minus 3 point, what is the value? It is minus 1. Okay, that is, this point is valid. Now let us take some positive value. Signum function of plus 3. So what will have? Mod of plus 3 divided by 3. Okay, mod of 3 means 3 divided by 3 is equal to 1. So for positive 3 value of t, that is 1, 2, 3. So at this point we have, what is the value? So this signum function has a value of 1. So this point is also valid. Now let us see what is signum function at 0 using this formula. So what will have mod of 0 divided by 0. So this is 0 by 0. Okay, so what is the 0 by 0? It is the undefined form. Okay, so this is undefined. So here we will assume signum function at t equal to 0 is equal to 0, because we can see here at this for definition itself we have here signum function has a 0 value at t equal to 0. So this is the third property. Now let us go to our fourth property. So in the fourth property we have d dt of mod of t is equal to signum function for t not equal to 0. That is differentiation of mod of t is equal to the signum function for t not equal to 0. Okay, for the positive and the negative values of t we have this relation. Okay, so this is the fourth property. So how to prove it? So from the third property we have signum function is equal to, what is the third property? So we have this relation from this third property, from property number 3. Okay, so property number 3 we have this one, signum function of t equal to this much for t not equal to 0, t into signum function of t is equal to mod of t. Now if we differentiate both sides, what we'll have? So d dt of, here we have t into signum of t equal to d dt of mod of t. So here we have dt will cancel, and here we'll have signum function is equal to d mod of t by dt. So here we'll have d dt of mod of t. Okay, so this is proof of this fourth property. Okay, that is d dt of mod of t equal to signum function. So here we have got this d dt of mod of t equal to signum function. Okay, so this is the fourth property. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.